Today in Greg Betts in Connected Components Workbench, we will be talking about user-defined function blocks. Wow, that sounds like a computer intro. Alright, so, anyway, right now I have some code written here. It's very simple code in the long run, alright? But basically, what happens, if we go ahead and watch it, and hit play here, as parts come in, they will come to the clamps. Once they're at the clamps will grab them, and then the clamps will release. Alright, notice that the conveyor belts are waiting now that those parts are there because it's saying, hey, there's already parts here, we shouldn't be loading the next one on. If we, and that's actually all the code that I had written really so far at this point. If I were to go to, if I would go and enable grab Z, or sorry, move Z, go ahead, move Z. You'll see that goes down, and if I grab it and I come back up, you'll notice that the next part comes down, and it's waiting basically for the same thing to happen. That clamp should go. Not sure why it's not. But anyway, the clamp should have gone, and the process will just repeat itself over and over and over again. Probably because I never reset clamped. That's why that's not moving. Now, so the name of the game here is we have code written, and if we look at my code very carefully, it's all of 6 lines, you'll notice right now the code is the exact same for both lines, or for both top 3 lines and bottom 3 lines. So for saying the parts are loaded, we care that, let's put this over here, parts are loaded, we care that the blue base at place, or the blue base at place or blue lid at place becomes true and then goes false again, so that's a negative transition. And that tells us that there is a part loaded up here. If there is a part loaded, we stop the conveyor at this point. That's all it's doing. Once the part has been clamped, basically, this is clamping and unclamping it right away. So actually, if I go ahead and toggle this one, it will clamp that next one again. And then again, basically, it's supposed to instantaneously open, but again, due to simulation speeds and things like that, it's running a bit slower right now. So if I go ahead and get rid of this part, I know where that went. If I unclamp, it's going to clamp it automatically. Unload, unclamp, you'll see that it's going to repeat the process. Now, this is all fine and good. All right, right now for this little conveyor belt, it's 6 lines of, or 3 lines of code per conveyor belt. Now, what happens if you realize there is a flaw on this one? Like, oh, this is supposed to happen and it doesn't. Well, then you have to fix these top 3 lines of code, and you have to fix the bottom 3 lines of code. And if you have 12 of these conveyor belts, you have to fix all of them at the same time. So you have to fix it, 12 different errors. It's the exact same error, but it's 12 different times. All right. Now, this is where the user-defined function blocks come in. So we can go ahead and add, gotta go offline, add a user-defined function block. And I'm going to go ahead and rename this right away. I'm going to call this conveyor. Now, as part of the user-defined function blocks, we have a few things we need to look at. So first, the code is just code, normal old code. Next, we have local variables. Now, I don't want to go into local variables. I actually want to right-click on this and say parameters. And I have my reason for that. So, let's backtrack just a little bit. So right now, if I want to call a function block, we normally would go to the top here and we'd say, okay, a function block would be an example, would be a timer. You'd go, okay, you drag your timer in. Notice you have in, pt, et, and q. All right. So whenever in is true, this runs. I wonder if we could actually, I don't think we can edit timers or anything else. That'd be kind of interesting to know. But anyway, so now if you notice, as soon as I created this user-defined function block, under favorites, or just to the next right of favorites, it says user-defined, and it says conveyor. And right now when I click on it, it just says en and eno. So inputs are enable and enable output, or whatever you want to call eno. Now if we go back to our little conveyor here, all right, we have a few options. So we can say a new input, a new variable, and a new output. If we do a new input, that will add more rungs to the left-hand side of this function block. And if we compare that to, let's do a count up, down. All right. So there you go. We have a count up, down time or counter. You can see we have CU, CD, reset, load, and PV. Those are all of our inputs. We have QU, QD, and QV as our outputs. So a lot of outputs going on there. Now if we come back to this and I look at my code, this is where the fun begins, because when you create a function block or a subroutine or a function or whatever you want to call it, all right, Connected Components Workbench calls it function blocks. RSLogix 5000, there are subroutines that you can create. It's kind of a mess when it comes down to it. Lots of different things call it lots of different words. So you kind of have to be a little flexible here with what we're calling it. I really overall like how Connected Components Workbench calls it a function block, and it actually deals with it just like a function block, which is really quite nice. It's a little bit nicer than the subroutines in RSLogix 5000 from my experience. So we need to create some inputs. Now if we want to do a very simple program, let's actually go ahead and create a new structured text, and we'll call this latching. A new function block. Let's go to our parameters there. So on our parameters, we need our start button as our input. We need another new input as our stop button. All right, those are booleans. We need a new output, which is our latch. All right, I'm just going to call it output, or no, I'll call it latched output. All right, and that's really all we need. So if we go ahead into my latching here, oops, I didn't make that a structured text. Can I change that? No, I cannot. All right, let's go ahead and do another one. A ladder diagram this time. Go ahead and delete my latching v2, because otherwise it's probably be mad at me. All right. And there's a reason I like the parameters. You'll notice as I put new input in, it does show up in the local variables. The reason I like the parameter screen over this is the order you have them in here on the left and on the right is the order they show up in your actual program. So that is why I prefer to do it this way. Alrighty, so that is all we need. And as again, you can see them in here. See, if I click on start button, it says data type, direction, that is key. This says var input. If you were to change this to a var output, and we go back to clicking on this, you'd see it's now over here on the right. So that is kind of a key fact there. So when you are creating these, if you are creating them in here, it's very important to have them happen over there as well. All right. Now, I also do like, or I do suggest, I guess I should say, that you also have your enable or in input, and we'll just drag that to the top there. All right, because if you want this to run like a true subroutine where you're just saying run this all the time, just run it first, or at this point in the code, you need to have something true there. If you want it to run like a timer where it only does something when it's true, then you don't actually need that enable there. I like having my enable there. So I'm going to have enable, start, and stop, and then my latched output after that. So, simple line of code in here. We do a little break. We do this, and we'll say that's our start button. We're going to latch it with our latched output. We're going to do normally close stop button, which is kind of important here that you do have this based off of what all of your sensors are. And then that will be our latched output. So now if we go back to my main code, come on. Let's go ahead and delete this and this. If we go, we have latching v2. It asks me for my start button, so I can come into this, and I'm going to use di0 as my start. I'm going to use di1 for my stop, and then I'm going to put an output after this of Of course I chose that. I need IO. digital output 0. So if we go ahead and download that, and we are downloaded. So let me go ahead and bring this back up. You'll see that it says start button false, stop button false, and our output is blue, which means it is false. And if we come down here, we see our output is off. If I click on 0, and I click 0 back off, notice 0 stays on. We got a red output. If I click on 1, it goes back off. So what this is doing is, let's go ahead and pause. Yep, we're disconnected. That's fine. If we come back in here, bring that down so we can see multiple things at the same time. All right. So what we're doing here is every time we're going to send in our input of di0, and we're going to basically name that start button for the entirety of everything happening in this function. And if I come back and look at that, I can see, so anytime you see di00, I'm giving it the alias of start button. So then we have start button right there, and then I have di01, that now has the alias of stop button. And you can see that. And then we have our latched output, and we're latching it down here with our little branch circuit. And then anytime that latched is true, it turns on our actual output. Now the glorious part here is I can, come on, there we go. I can use this over and over again. So underscore IO, I could say, okay, now let's use 2 and 3. And I'm going to just give that an output for my IO of 1 now. And if we re-download this and give it a second, now we can see that if I click on 2 and I turn it off, that works, and I click on that, and I can turn these off individually. Now, one slight problem, troubleshooting-wise with this, if I actually come look at my latching v2 program, it's never running as far as the software is concerned. Notice we've got no blue and no red lines here. And the reason for that, partially, is because we actually have multiple instances of this, and you could always have multiple. You could have 50 instances of the exact same thing. So when it's running this, it doesn't know, well, what time do you want to monitor it? Do you want to monitor the first time the function's called, the second time the function's called? What do you care about? So it gets rather, complicated to troubleshoot your stuff. So you really kind of want to start with writing your normal code, say, okay, everything's working fine, copy it into a function block, and then you have to go through and rename everything, which is where kind of the fun becomes. So that is one problem. Now, one really nice thing is if we actually go into our program's local variables, notice that we actually have a variable name called latching v2_1 and latching v2_2. And if we look at that, we can actually see the specific variables associated with those. So right now you can see the start button's false there, and if I bring my simulator back up and I click on 0, after a second, you can see that it becomes true, and if I unclick on it, it goes back to being false. But notice our output is still on. If I click on 2, now this output comes on. If I click on 3 at the same time, that turns off, but you can see everything else is. So you can monitor all of your variables associated with this at the exact same time as it's running. You just can't monitor it like looking at the normal code that you would think. So the function blocks are very powerful tools, but it does take a little bit of time to get used to. Now, this is going to be very helpful for your final, where you're going to have 3 different sorting machines. So if I actually go and look at my factory I/O here, I have sorting machine 1 and 2 here, and if I zoom out though, you'll see, or I have my 1, this is blue, there's my green, and if I zoom out even farther, there we go. There you can see a third one just waiting in the wings for me to set up. So it becomes a very powerful tool in the long run for you. Now you can see my second block showed up, and we're clamped, and we are unclamped now. So now the end goal for me here, at least for my purposes, is how I'm planning on doing this, is I'm going to have one function block that controls each sorter. And as long as I know that each sorter, the function block works well the first time, then I know as long as I have everything duplicated perfectly the second time, it will all work fine as well. So it kind of makes your life a little bit easier if you get your function blocks working well, because then you can use them for everything. So if we go ahead, let's get out of all of these programs that I don't actually care about. All right, so I don't actually need latching v2 anymore. Oh, and we crashed. All right, and we're good. So I can go ahead and delete my first line and my second line here. So now my end goal here is to move all of this into this program. And you have to remember, you have to pass the variables in. If you hard code, like if I put in this conveyor routine and I said global variable like green moving x, that will never change when I call the conveyor function block. It will always be green moving x. Where if I put in an alias for green conveyor belt, it will always change that every time we call that function block. And that is our end goal. So if we go back to my program and I copy my first 3 lines, this is how I would suggest you do it. You can come back in here and you can just paste those. Now, you need to determine, so let's go to our parameters list, what of this is an input, what of this is an output, and what of this is just a local variable that doesn't have to be sent out to the real world. Now, I always suggest putting your first input as just enable or en, just because that way it will always run your code whether nothing's true. It doesn't matter. Now, if I look at this, here are my inputs. So I'm going to say new input, and I will call that part at machine or part at clamp. Now, this is still following normal tag naming conventions, so you can't use spaces. You have to use underscores if you're putting spaces in. All right, and we'll call this part leaving clamp. All right, and then I have a new variable. Part base loaded is just a little variable that is within my function, so that's just a normal variable. So we can still call that. I'll just call that part loaded. All right, we're good. We're good. Base part loaded, base part loaded. We have an actual output. This is trying to control something, so we'll say an output here. And again, I like to have just a normal output at the top too. I'm just going to call it output. All right, we got new output, and I'm going to call this conveyor. Okay. We come down here. Base part loaded is still one of those. Base part clamped, that is another local variable that I'm controlling over here, so we can call that base part clamped, or part clamped. All right, blue base clamp, so that's saying it's an output. Ooh, this one never went to conveyor. Conveyor. I'm going to add sub because I think that's why. I think I have something else called conveyor, so it's not happy with that. All right, so now we can call this clamp out. Yeah, let's call this conveyor out. All right, and then base part clamped. That is an actual input. So I'm going to call that clamping detected, or clamping input. All right, and again, you can rearrange these as you see fit by click and dragging. So I always like to have my enable at the top, and my just an output or whatever at the other top, and we should be good to go on that point. Now here's the next fun part. I will leave. Can I leave that open? Well, I'll put it over on my second. Well, we can do that, and we'll shrink it some, and then pull this over here. There we go. So now the fun part is you have to transfer all of these. So base part at place, that is part at clamp. So part at clamp. This one becomes part leaving clamp. Okay. Base part loaded just becomes part loaded. Base part loaded, part loaded. Base part loaded, part loaded. Oh, part loaded, not part clamped. Blue base conveyor, that's our conveyor out. Base part loaded, which just becomes part loaded. This becomes part clamped. Blue base clamp, that is our output. So back to local, that is our clamp output. So clamp out. Blue base clamped, that becomes clamping input. And then base part clamped is part clamped. Alright, so we've got our subroutine set up. Now we need to call it, so we can go back to our main program again. Oh, main program. Let's go ahead and put a new rung at the very top. Go ahead and call our subroutine. So we have part at clamp, and that for my blue one, that is blue base at place. Part leaving clamp. For me that time this is blue assembled leaving. And we have clamping, which is blue base clamped. Alright, and then we have our conveyor out here, which is our blue base conveyor. And our clamp down here, our clamp out, which is our blue base clamp. Now, to save you all the boredom of me doing that again for my second 3 line of codes, I'm going to pause this. And there we go. I have converted those, so all 3 both are on 1 rung now. So we've gone from 6 lines of code to 1 rung of code plus our little function block, which has another 3 in it. So we're going to go ahead and download this with our project values. Other side, there we go. Yes. Alright, so you can see both conveyors are moving. We're just waiting for our parts to show up. Just go ahead and reset that. Alright, 1 got clamped and 2 got clamped. So everything is working fine. And again, if I come back into my global variables and I trigger the blue Z move, as soon as I go up with that, that's when the next one's supposed to start. And again, it still doesn't clamp it the second time. Same thing I can do for blue assembled leaving. If I come up here, I don't know if it's going to work. There we go. You can see the base one now works. Now, again, I have that problem where they're not clamping. That's because I never actually included that in my initial program. So I can now go ahead and add that, but I can only add it in one place, and both of them will be updated. So if I come back into my conveyor subroutine, and let's say as soon as the part leaves, we assume that it is unclamped. So we just got to put a little branch in here. There we go. Come down here, put another reset in, and we're going to call that part clamped. We can go ahead and download that. Hold on a sec. Alright, we are downloaded. We're running. So if I go ahead and hit play now, let's see our part comes in, both sides. I go back to my global variables. So you can see we're clamping both, which is beautiful. As soon as I move Z down, grab it and move back up, you'll notice that the next one starts to come into place, and this time it clamps it. So that one worked beautifully, and again, if I move my Z down and come back up, you'll see that that will have cleared that one. Now if we go ahead and trigger blue assembled leaving, and when I make that untrue again, you'll see my next one's going to come down, and now it's going to clamp. So now everything is working. So I fixed two problems with one code modification because both of them are relying on the same code. Now, as I said, the biggest thing that you need to remember when you are working with subroutines is that nothing in the subroutine gets hard-coded to a global variable unless that global variable is the exact same variable throughout all of your code. All right. So one example that I might have, instead of having my conveyor out be just controlled via part loaded, is if I wanted to have the system enabled, right? The conveyor out shouldn't move unless the system is enabled. That'd be a great reason to use conveyor out right here. All right. So that is just something to think about for your memory. All right. If you guys have any questions, please let me know. You are going to now. All right. I changed your assignment for last week, so that way it was just the go straight. Let me go ahead and save this. It was just the go straight on the weight challenge. And so this week you are going to add the left and right into that based on the weight. And you can do that using this new subroutine or function block. And if you notice, the left conveyor, the straight conveyor, and the right conveyor, they are exactly the same. They all have an input sensor, they all have an output sensor, and they all have a conveyor. So you can call the same function, and you can just change which function you're calling. So you can say, all right, go left, and you're going to call the left function. And you're going to say go straight, and you're going to call the go straight function. Or you're going to say go right, and call this go right function. But all of the code for all three of those are going to be exactly the same. So that will make your lives a little bit easier when you're dealing with this. And the nice thing is with these functions, you could have 12 different paths all controlled. You can, if you could have, we changed this up slightly and you had to go straight and then you had to peel left, peel right, so that way you could do 5 different weights. You could go left 1, left 2, straight, right 1, right 2. It would again be that same function. You just have to call that new function and say, the input for it is this, the other output for it is this, and the conveyor name is this. So you'd have one output, 2 inputs that you'd be passing into that, and maybe another output saying there's a part on it or not a part on it, depending on if the system's working. So it simplifies your life a lot when you are dealing with this. So function blocks, they're great. They're a little bit of complication, especially to wrap your head around to get them to work exactly how you want. But once you've got them working, you can just add more and more and more and more control outputs to it, and it simplifies everything. So that will make your life a little bit easier.